Hi, I'm Yeqing. Today, my teammates and I will talk about our final project, a chat web application. It has basic features like WeChat or WhatsApp. It adopts a publish-subscribe pattern to achieve asynchronous communication and uses pixels to make the service fault-tolerant in the distributed system. As planned in the project proposal, this application has three modules. You can see from the diagram that the first module is the user management. We integrated a third-party service called Auth0 for user registration and authentication. Because Auth0 holds its own servers and database, we call its public API to get all the registered users' information to display in our front end. The second part is relationship management. Because this is a chat app, each user can create new chat groups and users can subscribe to groups to receive messages. We use this module to record the group information. The third part is communication management. The idea is that a user will send a message to the backend. In the backend, there is some message controller, which involves the Paxos algorithm. The message controller decides if a message is successfully written in the database or not. If yes, it will notify the message queue about this message. The message queue will broadcast this message along with its chat group information so that the users that have subscribed to this chat group will receive this information in the front end. My teammates will show the web page and talk more about the implementation details later. Yeah, thank you.
Can I share the screen?
Sure, you can go ahead.
Okay. So for the front end application is built using React and Node.js Express. React is for building the user interface, and Node.js Express is for communicating between the message provider and the React user interface using WebSocket. So let me demo the application. So I created two user accounts. One is John Gmail, and then the other one is alexchange@gmail.com. And we can click on the plus sign to create a chat room. So let's say a chat room with Alex. And then we can select Alex. Or we can select multiple people. And then create. And the chat room will automatically show on the left-hand side of the navigation bar. But on the other end, the user account will only show the chat room when they refreshed. The application allow users to see the message histories and also allow to send new messages to the corresponding users. For example, if I send a message in the new chat room that I just created, so the other side will also see it instantly. So how can the client only listens to the message associated with the chat room the user select? In this application, each chat room's ID is uniquely generated during the chat room creation. The application uses the chat room ID as the topic and identifier in the publish and subscribe group communication model we are using. When the user selects the chat room label on the UI uses the WebSocket to communicate the selected chat room ID to the front-end server. The server will then send a request to the message provider to subscribe to the new chat room ID and unsubscribe the previous subscriptions. The message provider knows each message associated topics, so the provider will only send messages to the corresponding topic subscribers. So let me demo how when the application selects a different chat room, it will in the message MQ, it will change the number of subscribers. So for example, right now in the newly created chat room has an ID of 29. Now 2 people are selecting the chat group. That's why it shows 2. So if when Alex Yang selects a different label, and we can see it reduces 1, and then because Alex selects a different selects the ID 28, so it increased 1 and decrease 1 on the other end. So the application is also fault tolerant. When the connecting server fails, the application will try to connect with the backup server to keep the service going by looping through a list of backup service IP address, and we connect with one that is available. So let me demonstrate the code that does the searching for the available servers. So by default, when the application starts, each client is connecting to a default server URL and the message providers IP addresses or port numbers. And when the client sends any request to the server, you will have to go through this fetching method. And what it does is in this fetch request, it will first send the request to the default server URL, and it will check if the result come back as 200, which is success. If it's not, then it will start looping through a list of the URL, the server URL, and trying to find the one that is available. It will first connect to the respective port number, the message MQ port number, and then it will try to send the request again to the server. If it's success, then it will return to the user. If not, then it will go to the next one. As you can see, if it's 200, then it will return, and if it fails, it catches the error and it will continue and loop to the next URL. So let me demonstrate the reconnection. So right now I am connecting to only one server. So let me turn off the server. So now when the client open, so when I try to send a new message out, as you can see, the client server is keep looking for a new URL that it can reconnect. Since I only have one server connected to one server and none of the servers are available, it will return all servers are down. Next, Tianyu will show you how the backend works and how the front end connects with the backend servers when the connecting node fails. I will let you share your screen, Tianyu.
Hello, I'm Tianyu, and I want to introduce the backend part. So let's look at my README. there are many features of this backend part, and the most important one is that we implemented it with the Spring Boot framework. This framework, it gives us a lot of useful annotations. For example, the post mapping, response body, request body, it helps us with the communication, and resource, it helps us with the instantiations of classes in our project. So it really speeds up our development a lot. So the second feature is we implemented Paxos to ensure the fault tolerance. So for every server, we have provided some APIs like accept, promise, learn, and something like that. And we give out the proposer functions to this server. So we just implemented the Paxos so that when we, for example, if we have 5 servers and 2 of them are down, our project will still run. And so the next feature is information of all participants, which is our servers in this Paxos group are recorded in the address table. So it's actually in our database. And then how do we instantiate this table, fill it out this data? We just used a SQL script and write it here. And then when we deploy this MySQL database, we just run this, and then we just run this, and then this script just runs this one. So a project is deployed in a bundle. So actually, if we deploy 5 bundles, we'll have 5 servers, 5 MQs, and 5 databases. It's really fault tolerant, and the instances communicate in a local network, and that's why we see we have created something called project network. And then when we instantiate any instance, we just run it with this network so that they can communicate with each other. So the 6th feature is that we used MapBase Plus to help communicating with database. Normally, we should write down XMLs, or at least we should write some SQLs to communicate with the database. But right now, we have this MapBase Plus, and we can write things just like that. You see, we can just extend some service info from that MapBase Plus, and this class, it has so many methods, just like save or update or something else, just like the normal CRUD SQL operations. And then we use the Lombok to cut down the cost of writing modules. Notebook is just like that. We write an iData annotation here, and then we have all the getters and setters here. Even if we can't see it, but it's exactly there, and we can call the getters and setters outside. A whole bundle can be deployed with the one script. It's just we only need to run the run bundle.sh to deploy the whole project. I mean, one bundle. We have covered the deployment of MySQL database in this shell, and the shell itself will run a server, and other MQs are currently pre-deployed in a deploy phase. So actually we need to deploy it first, and then we need to run the run bundle.sh how many times we need. So we also used a reflection to generify the Paxos process. It's just like that. Our Paxos, it doesn't handle the operations case by case. We just offer something of operation, and this operation is consists of the method name, and the args is an ID, and the class name of its args. And when we just stand it out, it will be decomposed. And when we want to execute it, it will be composed just with the class name and method name. And we used some utils like this reflect method, and okay, this is for another class. Just we use this one to do this reflect. The next feature is that the communication is implemented with message passing. So actually, all things are passed in the JSON format. Just you can see in the controller. The backend, everything is a JSON object or just a single basic format. The next one is that we use the ActiveMQ to push messages to the front end. It will be introduced by Yung-Shin later. So the next feature is that timeout is currently set to 2000 milliseconds right now, and they can be edited altogether. Just we have some common post method here, and we can just edit the timeout just in this 2000 way. Here, our current deploy script is made for macOS and Linux, and it needs some adjustment if you want to apply it on other platforms. I think it's just like these volumes, it doesn't exist in the perhaps Windows system, and something like a platform equals Linux. AMD 64 is required in macOS, but perhaps it will result in some problems in other systems. Yeah, so that's the features. And we also have a Swagger page. It's like that. With this page, you can test. You can know all the parameters and something like that about our controller, and also you can test it here. You can edit your parameter here. So then we come to the deploy part. In the deploy part, we have two phases. The first phase is that we need to run the deploy.sh. And in this phase, we can generate our server image first. Yeah, we generate our jar file first, then we generate our server image, and then we run the launch active mq.sh, and all the mqs here will be generated. After that, we can run the run bundle.sh, and here the mq IP should be the should be one of the mqs we just generated before. For example, we want to generate a MQ called MQ1 here, and MQ2 here, MQ3 here. Then this MQ IP, when we insert it, it must be one of the MQ1, MQ2, and MQ3, just like that. So yeah, each execution of the run bundle.sh generates a new bundle, and the status code 0 indicates success, and the status code 1 indicates failure. So perhaps our client can do some judgment based on this status code. And initially, we configured server 1 through server 5 in our SQL script. You can configure what you want, the number of the servers in the address, and if you just put 3 here, there will be only 3 servers in this bundle and in this Paxos group. And if you just configure 5 here, it will be 5. Okay, let's come into our demo here. And how do we instantiate our project? We should first // deploy.sh. We will wait. So it starts to generate the MQs. Yeah, the deploy phase is done. So now we come to the run bundle phase. You see, there were 6 parameters here. The first parameter is the name of the server. The second one is the port that is exposed to the local host of the server. Then DB1 is the name of the database, and A001 is the port exposed to the localhost of the database, and data one is where you mount the database volume to the outside, to the dyno, and then the last one should be the name of the MQ. So we will just run it. Just almost the same, but they're different. 3 bundles. I will wait when it's done. Yeah, it looks like the server is almost down, but we need to wait until the database is okay. It seems that it runs right now. All right, let's check how it works. I did just a minute. Yeah, I do. I'm on 2 pages here. Let me close this page and yeah, 2 pages run now. And I wanna, this one I log in as Alex Yang, and this one I log in as Tianyu. So I wanna create a chat room. Alex. And all right. And what I want to create. Yeah, it's here. And here we want to just perhaps we want to refresh it, and then it appears. Just a minute, it logs out. I don't know why. So here we want to send out a message, perhaps as S. Oh, just a minute. We need to click the chat room button, and then we want to send it out. Actually, do we have MQ here? No, the MQ1 is not working. So sometimes, you know, there may be some bad things happen when you run the deploy that as such, so that some of the some of the Docker containers will just exit automatically. So at this time, you just need to run it again, and perhaps it works. Let's check. It should work right now. it finds the MQ. It seems like that the front end.
I think you will have to close the browser and then be open again, because technically you have to start the message provider first before you can start the client. Actually, yeah.
You mean I need to refresh it, or
just close it completely and then just reopen the client.
it's kind of okay. I'm sorry.
No, what I'm trying to say is you have to shut down the server.
Wait.
No, the Express.
What do you mean? You mean that this one should be shut
Yeah.
down?
Yep. You have to, because the MQ has to start first before this one.
All right.
Because otherwise it won't subscribe, right?
Yeah. So the other one should also do that. Good. And here, let's try to do it again. Oh, good, it works. And
There we go.
on the other one, yeah, we need to log in here as that one. We send 3 queues here, and then we got it here. That's good. And then we want to do some challenging works, just like perhaps I'll shut down the server 2. Yeah, then the server 2 is shut down. Let's see whether it still works. Yeah, it still works. So let's do some other challenging works. We want to recover the server 2, and then when we shut down the server 1, we know that initially the front end connects with server 1, and what will it do if the server 1 is shut down? It will connect to server 2 right now. So let's wait until the server 2 database is all right. Just to use the refresh to check whether this database is ready. All right, it looks good. Okay, so we want to do it again, and it looks good. And let's check our second page. It's good. So I think my part is done. Let Yung-Shin share his screen.
Okay, thank you, team. So now I'll just give a quick introduction to the detailed implementation of our message processing. So first, this is our message schema we have. And the first one is the message ID that we automatically generated at the server. And from the front end, we will receive the group ID, which is the ID for the chat room, and the sender ID, so that we know, like, inside a group which one sends this message, and of course the message content. So to avoid like confusion with like timestamp, for example, like two people like sending at the roughly around same time, or like people sending from different time zone. So we create this timestamp at the server when we receive this add message request. And so this is the first part. When someone sends a message from the front end, they call this message add. And this message add is sent to the server. So the first thing we do is to set the create time for this message. And then we do what Tianyu just said about pixels. So after pixels done, like servers are good, we put these message to our, we commit this message to our learners. And at the same time, we tell the front end that, okay, you can now display this message. So for other people inside this chat room, we'll generate a, because of the group ID that is sent from the front end. So we know the topic, what the topic is, which is the group ID. So we send this message to our message provider, which is which we use is ActiveMQ, with these topics and the message content. So the people inside this chat room, they will, which are the subscribers, will be able to receive this message according to the topic, which is our group ID, the unique group ID for this chat room. And the next one is list message. So this function is called when someone clicks on the chat room. So if they want to see the message history inside this chat room, they will call this function. And when the server receives it, it has to be called with the requested group ID, which is the chat room they want to see the message. And so we go to our database and find the messages that belong to this group ID, and we send it back to the front end so that they can display the message history. And this is the introduction to our application, and we hope you enjoy this video.
Thank you.
Thank you.
Thank you.
这样应该 OK 吧？我感觉大家都表演天才，
We're still
应该一
recording.
次就可以。